Hi everyone, in this lesson we are going to look at why we need to use constant total volume when we want to answer clock reaction questions that involve mixing different volumes of solutions together. So if you can recall, right, when we calculate rate, we usually use the rate equation, and A and B is usually represented in its concentration and not volume. So we are going to use volume total, all right, and we are going to keep the total volume constant, because when that happens, all right, what we'll get is this phenomenon where the concentration ratio is the same as the volume ratio. In other words, concentration is proportional to volume. So if you remember, we usually use this equation of C1V1 is equal to C2V2. So imagine I have a stock solution, right, of concentration C1. Okay, no matter how I mix these things, C1 will always be a constant because it came from the same solution. I didn't do anything to it. Alright, and V2 is my V total, which in this case is a constant. So this C2 here is the new concentration that I'm preparing, and the volume V1 is the volume of this solution that I'm using. So since C1 and V2 are constants, okay, I can just group them together, and what I will get at the end of the day is V1 is equal to C2 times V2 over C1, in which this whole part is a constant. Therefore, V1 is equal to C2 times a constant, right? This K is not the same as this K here. This is just a constant, a random constant. And with this, it looks like your Y is equal to Kx kind of relationship where volume is proportional to concentration. So the concentration that we make depends on the volume of the solution, the stock solution that we use. And that is why, to make life simple, all right, we usually use a constant total volume by adding extra DI water so that the volume remains constant. Therefore, we can use volume of both reagents A and B as a proxy for its concentration.